Welcome to Developer Roadmaps. Today, we're placing a really critical checkpoint on our journey, software testing. Now, this isn't just about hunting for bugs, it's about building the confidence you need to ship code quickly and create products that are solid right from the start. Let's map this out.
Before we even think about writing a single test, let's just take a second to understand the stakes. Because, inadequate testing isn't just about some minor glitches or a bit of user frustration. When critical software fails, it can have massive, real-world consequences.
And I'm not exaggerating. We're talking about everything from tragic airline crashes caused by a software flaw to billion-dollar satellite failures to major financial markets getting completely disrupted. These incidents are a powerful reminder that software reliability, it isn't just some nice-to-have feature. It is absolutely essential for safety, for financial stability, and for trust.
So how do we even begin to prevent these kinds of failures? Well, we start at the smallest, most manageable level. Let's place the first checkpoint on our roadmap, securing the foundation of our code with something called unit testing. The whole goal here is simple, but it's incredibly powerful. You want to isolate each individual building block of your application, a single function, a single class, and prove that it behaves exactly as you expect it to. We're not worried about the whole system just yet, just whether this one little piece of code does its one job correctly. So what's so great about them? Well, it's all about that rapid feedback loop. Because they are super fast and designed to be run all the time, unit tests act like a safety net. They catch bugs the very moment they're introduced. And trust me, that makes them way cheaper and faster to fix than if you found them weeks down the line. And this right here, this comparison really gets to the heart of it. Unit tests are absolutely essential, but they have blind spots. They're fantastic at confirming that your individual code blocks are solid, but they just can't see the bigger picture. They have no idea if two perfectly coded modules will completely break when they try to talk to each other. Okay, so our individual components are solid, but what happens when they actually need to work together? It's time to place the next checkpoint on our roadmap and dive into integration testing, which is all about checking the connections between our pieces of code. This is where we make sure that all the different parts of our application can communicate effectively. Think of it like this. If unit tests check the individual bricks, then integration tests check the mortar that's holding them all together. We're specifically looking for flaws in how data flows and how the modules interact. And this is that aha moment for so many developers. You can have two modules that pass every single one of their unit tests perfectly. The login module works, the mailbox module works, but the second they interact, a bug appears out of nowhere. Maybe one module sends the user ID as a number, but the other one was expecting a string. This is exactly why you need both types of tests. All right, so we have our core building blocks, unit tests and integration tests. But how many of each should we actually be writing? For that, let's look at the master plan that guides our entire strategy, the test automation pyramid. So the whole strategy starts with this wide, stable base. It's made up of a large number of fast, low-cost unit tests. Because they can run in milliseconds, they give you the quickest possible feedback. And they really form the bedrock of confidence in your code. This is your first line of defense. As we move up the pyramid, we have a smaller, more focused layer of integration tests. Now, these are a little bit slower. They might need to talk to a database or an API, but they are absolutely crucial for verifying that our core components are communicating correctly and that the data flowing between them is valid. And then right at the very top, we have the fewest tests of all, the slow, complex end-to-end tests. These simulate an entire user journey, like from logging in to making a purchase. And while they give you the highest level of confidence that the whole system works, they're also the most expensive and time-consuming to run. That's why we use them so sparingly. This chart just perfectly illustrates the core principle. The ideal test suite is bottom-heavy. You want many fast unit tests, a moderate number of integration tests in the middle, and just a very few slow end-to-end tests at the top. Following this kind of ratio is what keeps your whole test suite fast, reliable, and easy to maintain. And this strategy, it aligns perfectly with modern Agile development. By creating these really fast feedback loops, developers can catch issues right away, they can refactor their code with confidence, and just iterate much more quickly without ever sacrificing quality. So we have our strategy, but the real power of this pyramid is unlocked when you automate it. So let's look at the final destination on our roadmap, integrating all of this into a continuous quality process. See, by integrating your entire test suite into what's called a continuous integration and continuous deployment, or CICD pipeline, every single time you commit code, it automatically triggers all of your tests. This means you get this constant, automated check on your code's health, catching bugs long before they have any chance of reaching your users. And this is the real destination on our roadmap. It's a state where quality isn't some final step you do at the end. Instead, it becomes a continuous, automated, and totally integral part of your daily workflow. It's how modern teams really build robust and reliable software at scale. This is Developer Roadmaps. Map your path. Build your career.